35 questions.
Yeah,
It sounds like a lot.
yeah. I was on question 15. I was like, I'm gonna go ahead.
I don't know.
It's festivals and all that. Oh my gosh. Big growth. I would totally. I totally do. Yeah. Yeah, I'm just saying, yeah.
I've been there since. It's like 9,000 people.
Yeah.
Stadium, right? It's so big.
I want to go to the same. Huh?
Yeah, but
She said I wasn't really. When I moved after you. You're not really.
terrible.
No, I'm just making So is that what we're gonna do? That was what we're doing. It's yeah.
Yeah, the thing listed as homework quiz 1, that's just a collection of homework problems from the textbook or from the publisher stuff. That's not the actual quiz. The actual quizzes will show up in the quizzes and test section.
I see.
So right now there should be one thing that shows up on the quiz and test section, and then there will be another one that'll show up tomorrow morning after this class. That'll cover the material.
That'll be the one.
That'll be the one that you need to take. And I think I have it set up for you guys to have until Friday of this week to finish it. And it's only like 10 or 11 questions on there, so it's not, it's not designed to make you stressed out. It's not, it's supposed to be like, it's not supposed to be like there's 35 questions and you have an hour to do them, and if you don't get done, you don't get full credit.
So if I'm already stressed out.
If you're already stressed out, then you need to change. You need to have like chai tea or something, maybe go for like a massage or something. I'll talk a little about that. Yeah, we'll get it set up. I was looking and I noticed that there's only 15 enrolled in the course compass stuff yet. As I said, the first online quiz starts tomorrow, and you have until Friday, so you need to make sure you get enrolled before it's due on Friday. Okay? All right. All right, let's go ahead and get started then. Today we're going to get into probably section 1.3. We're almost finished with section 1.1 on the domain range and simple function stuff. We'll go through 1.2 a little bit quicker, and then hopefully get into 1.3 on the trigonometry stuff before class is over. Some of the stuff in these sections I'm going to have to ask you guys to look over on your own. A lot of this material should be fairly familiar to you, and I don't think it's unreasonable for me to ask you to look it over without covering it really in depth in class. If you have questions or concerns over it, I welcome you to come and see me. Send me an email, go see Jason. That's why we're here. We're here to help you guys with the material if you're having trouble in school. So feel free to stop by and see us as you need to. All right. So let's go ahead and finish the 1.1 stuff. And really the last step out of this section is just identifying some common graphs of some common functions. For the most part, this section deals with graphs of very basic functions, like linear functions. it, a little bit about polynomials. So, start off with just asking about power functions. So power functions are basically just functions that involve power of x. And not only that, but they're functions that just look like y equals some power of x. That's it. That's all a power function is. Something that looks like y equals a times x to some power. And the key thing here, the power that we're talking about here, the powers are always going to be integer values. You're not looking like x to the 1/2 power. That's not a power function. Okay? We're just looking at functions like y equals ax to the n, where a is a real number, and n is a positive integer. Now, graphs of these functions are very straightforward and basic. Okay? They have some very similar shapes, some very familiar pictures that you can get out with these power functions. The first ones, if we look at y equals a to the x. Functions of this type are called what? These are linear functions, okay? Now, obviously we can change these linear functions to put constants on the end. It's not going to change the overall shape. It's just going to change sort of where it crosses the y-axis, okay? So functions like this, these are linear functions, graphs of linear functions, lines, something like this. Let me graph the general form that I have listed here. Linear functions of this type all pass through the origin. They have a decreasing behavior when a is negative. And obviously they have increasing behavior when a is positive. So this is a greater than 0, or a less than 0. Alright, so linear functions, pretty straightforward. We move up the chain, we go to the next power. So y equals ax squared. Functions of this type are called, off your head, you remember? Quadratic. Quadratic. Okay. Functions with squares as the highest exponent are called quadratics. These again have some familiar shapes. We looked at some of these last time. A quadratic function has this nice U shape. Okay? It's opening upward when a is greater than 0, and it opens downward when a is less than 0. Okay? Alright. All of these have their vertex at the origin. As you increase the value of a, you sort of just increase how steep this curve gets as you move away from the origin. And one or two more. Y equals ax cubed. These are cubic functions. Cubic functions have a nice graphical picture as well. These sort of look like a chair. Kind of make them look like a chair. Key thing about cubic functions is that cubic functions will always start in one of these two quadrants over here. It will start in either what's called the second quadrant or the third quadrant, and they will always end in the quadrant diagonal to them. So in this case, this is if a is greater than 0. A greater than 0, our quadratic function starts out with very large negative values on the negative x side, and then those lead to very large positive